Position, velocity, acceleration. What relates all these things together? Kinematics. Kinematics applies to a lot in our daily lives, such as playing catch. Let's dive deeper into kinematics. Alright, so when an object moves, its position is changing. Now, velocity describes the rate or speed at which the position changes and in what direction it changes. Acceleration describes how velocity is changing, the speed or rate that velocity is changing and in what position. Now, we have several equations we can use to calculate some of this, such as the velocity final is equal to the velocity initial plus the acceleration times time. We can also relate these three concepts through calculus. For example, velocity is equal to the derivative of position over time, and acceleration is equal to the derivative of velocity over time. We can also go backwards using calculus as well. For example, position is equal to the integral of velocity with respect to time, and velocity is equal to the integral of acceleration with respect to time.
In a lab setting, you can use kinematics to figure out how fast it would take this beautiful piece of tape or roll of tape would take to fall to the ground without using a timer. So, if we measure this, let's say it's 1 meter, and we drop it. Now, you see the height is 1 meter, so we can use the x final equals x initial plus velocity times time plus 1 half at squared. Initial velocity is 0. And the height is 1. So if you solve for time, it becomes the square root of 0.2, which is around 0.45. So I think that's pretty reasonable, right?
Kinematics in real life is with driving. If you know that a car is starting at rest, and you know the final velocity and the distance, you can calculate acceleration. Using the equation, velocity final squared equals velocity initial squared plus 2 times acceleration times distance. Now that's acceleration.
Alright, here we go.
No, oh my gosh, we're gonna go so fast! We're gonna go so fast! Oh my god! Oh my god! Ah! Ah! Yeah! Whoa. Wow. Woo. 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 Woo.
Alright, we're good.
Woo. Yeah. Shout out to my fans out there. Woo! My god!
Alright, happy Tuesday. All phones away, notebooks out. Justin. Alright, so for our warm-up, we are given velocity initial is 0 meters per second, velocity final is 6 meters per second, and time is 3 seconds. Find the acceleration.
Wait,
Alright, time's up.
No! Wait!
Alright, so for this question we use the equation velocity final equals velocity initial plus acceleration times time. And so 6 equals 0 plus acceleration times 3, and acceleration equals 2 meters per second.
Oh, I thought it was D. Dang.
He trolled us.
Okay.
Alright,
Can
and
we
for
start
the
over?
second equation, or second question, velocity initial equals 30 meters per second, acceleration equals 2 meters per second squared, and time equals 10 seconds. Find
The
final
bell
distance.
rings.
Saved by the bell.
Do you not have enough energy? Are you always feeling tired? Do you wish you had more motivation? Introducing the desk. Within a magnificent height of 0.8 meters, this device can increase your potential energy. So how does it work? Well, you see, potential energy is measured by mass times gravity times height. When you get on this desk, your height will increase. Here's one of our satisfied customers. As you can see, he is very tired. But with the new desk, Energized.
Scientists all over the world has claimed this to be true with the equation PE, potential energy, equals mgh. You increase h, you increase potential energy. That's a direct relationship. You can get your very own desk with 7 easy tenets of your life savings. But wait, there's more. If you call now, we'll add another desk for the exact same price.
Whoa!
That's right, that's 2 desks for the price of 2 desks. Please note that this product is not used for negative. Side effects may include acrophobia, nausea, dizziness, diarrhea, or weakness. Batteries not included. Please do not use the product if you're pregnant, had a child, or human. This company is not responsible for any injuries sustained while using the product. Please buy now.
Gravity is the force of attraction between masses. Beep, boop, beep, boop, beep, boop. Gravity affects us every day. Here, catch. Even though we talk about it most with planets, gravity can happen between any 2 objects. We're all attracted because of gravity.
Hey, Ian, the science guy.
Hey, Minwoo, how's it going?
How you been, man?
I'm good. How are you?
What are you
Hey,
doing?
Check this out. So, watch what happens when I drop this piece of paper and this ball at the same time.
Whoa! That was pretty impressive. But why didn't they hit the ground at the same time?
So you see, gravity on Earth causes everything to fall towards the Earth at 9.8 meters per second squared.
Oh.
But the reason why the paper didn't hit the ground at the same time as the ball is because air resistance acts more on the paper than it does on the ball. But if we do it again, if we crumple up the paper into a little ball and we drop them again,
Uh-huh.
woo! They hit at the same time.
Yeah, that was so cool.
Today, we're going to go talk to Dr. Kim, who has a PhD in culinary and ramps, and is certified in ramp CPR and also ramp surgery. He has been awarded the Nobel Physics Prize for the discovery and the angle factors of gravity on ramps. Let's go talk to him. Dr. Kim, good to see you.
Good to see you, old sport.
What are we doing today?
Do you see this beautiful creature? It's the ramp. We will be talking about the factors that a ramp has on gravity.
Can't we just use a normal gravity equation as if we were to drop a ball?
What? The normal gravity equation? No! We have gravity. But what is this? What is this? Do you not see this?
A ramp.
It is an angle. And if you look very closely, Hmm. 180 minus 30 degrees. There's a 30-degree factor in here. So what does that look like? Look very carefully, old sport. There is a parallel component and a perpendicular component to any object that is on this ramp. And since the perpendicular component cancels out, old sport, it is the parallel component that affects the gravity. And what does that look like, old sport?
I don't know. What does it look like?
mg sine theta.
Awesome. Thank you very much for your information. It was great talking with you.
Yes, it was great talking. Let's get out of here.
I know his name, Sir Isaac Newton. He discovered gravity. An apple fell down on his head and then was able to comprehend this concept of gravity, which is 9.81. Have a dream, I hope will come true, that you're here for me, and I'll fall for you. We're falling together because of Big G. Oh boy, how I love our gravity. Hey boy, how I love our gravity. Hey boy, how I love our gravity.
Oh, don't you dare look back, just keep your eyes on me. I said you're holding back. She said shut up and dance with me. This woman is my destiny. She said ooh, shut up and dance with me.
I'm recording right now.
Okay, we're good. Alright, we're ready.
Now you're ready?
Oh, you're recording it?
Donuts.
Oh.
Min accidentally stopped recording, so. Alright. Here we go. Oh wait, it's in reverse. Alright. Here we go. Oh.
Oh my god! Oh my god! Ah!